Okay, in our class today we talked about systems of equations, what they were, solutions, how to work with all this stuff. And so I want to just recap what we went over today and then maybe solve a couple problems for you on your homework. Systems of equations. First we said a system of equations. All that meant is that we have two lines. System because we have more than one, equations because they're lines, so we have two lines. And we said, okay, if a system of equations is two lines, what are the two things that two lines can do? What are all the things two lines can do? Well, if I have two lines, and here's just three quick sketches. If I have two lines, one of the things that they can do is intersect. One of the things they can do is they can be parallel, so they don't intersect. And the other thing, which blows everybody's mind, is they could be the same line. Did you see that? That's two lines, but it looks like the same exact line. So we could have three things happening. They can intersect, they can be parallel, or they can be identical, the same line. That's what happens if you have two lines. So system of equations, we're just looking at two lines. We're looking at what happens is it one of these three cases, and if they're intersecting, we want to find out where do they intersect. So the whole goal of this is find out where they intersect. In fact, the solution to a system is right where the two lines. A solution to a system is the intersection. It's where the lines cross. Where do the lines cross? Where the lines cross. That's what the solution is. The solution is where they cross. Solution is where they cross. So in terms of that, if we're talking about that, how many solutions does this one have? It has one solution since it crosses once. Parallel lines have zero solutions because they cross never. Identical lines have infinite solutions because they cross everywhere. So intersecting lines have one solution, parallel lines have no solutions, identical lines have infinite solutions because these cross once, these never cross, these cross all the time. We can actually identify these things without actually doing any work. Identical lines, well, they have to have the same slope, go in the same direction, and the same y-intercept. Those are the things that have to happen for it to be identical. Parallel lines have the same slope, but different y-intercepts. Look, same slope, same directions, but different y-intercepts. They're crossing the y-axis at different spots. And intersecting lines have different slopes. Different slopes. One's going this way, one's going that way. They have different slopes. And as long as they're different, they intersect. If they're the same but different y-intercepts, then they're parallel. If they're the same slope, the same y-intercept, they're the same line. You have two problems on your homework, 19 and 21, which asks you to do something just like that. 19 says, are these lines, which one are they? Intersecting, parallel, or identical? Same slopes, parallel, because they have different y-intercepts with the same slopes. 21, you have y equals negative 3x plus 1, y equals 3x plus 7. Are those parallel, intersecting, or identical? Different slopes, they're intersecting. See if easy work like that, and those two are off your homework. The next thing we did, after we made this little chart about intersecting, parallel, identical lines, do the pictures, different slopes, same slopes, that whole deal, is we said, well, let's find out where two lines intersect. Let's actually look at a system. And this one's off your homework. Here's a system because it's two equations. Here's my system. Find out where these two lines intersect. Well, the only way that I know how to do that is by graphing right now. So I'm going to go ahead and graph those. When we graph, remember, you want it in slope-intercept form. Put the slope on the graph, put the y-intercept on the graph, and then put the slope on the graph. So when you graph it, you're going to go, okay, is it in slope-intercept form? What's y-intercept? What's the slope? Number one, is that in slope-intercept form? Yes, because y is by itself. So we're going to go, okay, y-intercept is 2. Slope is 1 over 1, so we go up 1 over 1. Which takes me right there, and that gives me a line that looks like that. You have graph paper at home, so it should be looking really nice. This one's, I don't know, graph paper, so it looks kind of trashy. Y equals negative 2x plus 2. On this one, is it in slope-intercept form? Yes. The y-intercept is 2. The slope is negative 2 over 1, so we go down 2 over 1. That line goes right there. I want to know the solution is where those two lines intersect. Where do they intersect? That's an ordered pair. 0, comma, 2. 0 on the x-axis, 2 on the y-axis. So the solution to this system is just this ordered pair. It's where do they intersect, and it's right there. A few more problems like that. I want you to try those on your own, graphing them, and we'll pick this up tomorrow.